going to think about our ditributent. Okay. Finally, that brings us to number 6, which is our structures. So I do have one of these definition sheets again, where we have our electron dot structure, or our Lewis dot diagram, which is going to show how those electrons are shared between different elements to actually make a molecule. We have our steric number, which is the amount of substituents or things off of the central atom, and this one is going to be including those electron lone pairs, which is important because it's a little bit different than those bonded number of atoms. For our electron group arrangement, we have how the molecule is actually configured, and we want to we can look up or find the molecular geometry chart that the lab gives us, and this can be very helpful. We have our number of bonded atoms, or just the substituents to the central atom that are other atoms. We have our molecular shape, which is how the molecule is configured with lone pairs taken into account, so if they were kind of invisible. And then we have polarity, which is going to be a larger change in electronegativity across a molecule. So just a quick little note on this. If we have something like water, where we have 2 lone pairs off of our oxygen and then we have hydrogen, we can look at an electronegativity chart, but we know that we're going to have a partial positive over here because these hydrogens are going to be donating their electron into this oxygen, which is going to give us a more negative portion of our molecule here. So we could say that this is polar. Whereas something like methane, where we have CH4, we have a lot of our hydrocarbons we want to think of as nonpolar, and even more so for this particular one is if we actually were to do the electron geometry out, we would see that there is no dipole moment, which is what we drew here, so we would consider this nonpolar. And this will become more interesting in our next ones, or in our next labs. So I did want to go over two of these ones. So when we have something like water, we want to think about our electron structure as our 2 hydrogens connected to that oxygen, and we also want to draw in our 2 lone pairs. Now we'll notice we talked a little bit about that octet rule, and we have 2, 4, 6, 8 electrons surrounding that oxygen, which means that oxygen is happy and satisfies the octet rule. We then will have that steric number, and we have 1, 2, 3, 4 different steric things coming off of this central atom. Our electron arrangement, so if we have 4 things coming off, we think about it as a tetrahedral. And this is where our molecular and electron geometries chart will really come in handy. I wish I had one printed for you guys. Unfortunately, I don't, but there is a nice one in the pre-lab for this particular experiment. The number of bonded atoms, so we have the 2 different hydrogens. The molecular shape, so if we were to look at this without the presence of those electrons, this is what we would call bent. Excuse me. And one of the things that you want to kind of think about is our molecular shape is based off of our electron arrangement. So we have our tetrahedral, so I'll draw out the tetrahedral here actually. So this is just a quick example of one. And I'm just going to put X's on the sides. And I'll put a carbon in the middle, why not? So this would be a tetrahedral. And then if we got rid of one of those groups, so if I made this into a lone pair, we would then have this structure, which is called trigonal pyramidal. And if we're getting rid of one other one, so we'll have our carbon, X, another X. This is where we have our bent. And And what's important to note for these is we still have those lone pairs. We're just not drawing them in on here. I will draw them in just so you guys can see that though. And if we're looking at this, we do know, yes, it is going to be polar because we have this area of greater negative, and then we have these hydrogens which are going to be more positive because they're donating that electron density, donating the electron density in. The other one that I'm going to walk through with you guys is CO2. So I'm going to put my carbon in the middle. I know that oxygen wants 2 bonds and carbon wants 4 because we have 2, 4, 6, 8. So that means that our carbon satisfies the octet rule. And then I have 2, 4, 6, 8. So that's going to satisfy the octet rule as well as these two. For this, my steric number ends up being 2. And this is because I've got 2 different things attached to that carbon. Our electron arrangement is considered linear. We have 2 different bonded atoms. Our molecular shape also is linear, and this ends up being nonpolar, so no, it is not polar. So that is about the end for this particular lab. If you guys have any questions, please feel free to visit us at office hours. We're available Monday through Thursday from, I believe, 11 a.m. to 7 p.m. So please, I urge you guys, if you do have any questions, feel free to visit us or email us as well. And good luck on your exam on Friday, and have a good rest of your day. Hopefully you guys can get outside too, because it's a beautiful day out.